Smart Heritage for Urban Sustainability, A. Review of current definitions and future developments. By PhD candidate Heng Song and Professor Dr. Gehan Selim. Article info. Article history. Received, June 24, 2022. Revised, August 25, 2022. Accepted, September 3, 2022. Available online, September 12, 2022. Keywords. Architectural heritage, smart heritage, urban sustainability, heritage, smart cities, integrative review approach. Abstract. Smart heritage is still novel in heritage discourse, with a few relevant review articles. In this regard, a specific interpretation of smart architectural heritage and a framework for instructing its development is lacking. This article reviews the literature on smart heritage and sustainable development to fill the knowledge gap. The integrative review approach and thematic analysis are adopted to review references located at the crossroads of historic, smart, and sustainable disciplines. The review and interpretation draw on literature from relevant fields to understand implementations, current states, and support to interpret smart heritage. Review. Outcomes indicate that smart heritage is becoming dynamic as technologies are increasingly applied to more detailed heritage branches. This article lists the factors that heritage should possess to be defined as smart, and it provides a framework that might be followed to achieve the aims of this discourse by stating that smart heritage discussions are relevant to smart cities, as they may have a mutual effect and interact to promote each other. This article is an open access article, distributed under the terms and conditions of the Creative Commons Attribution 4.0 International, CC by 4.0. 1. Introduction. Topics around sustainable development have been evolving for more than 30 years. Environmental concerns, energy decisions, social issues, and other aspects of urban development should be integrated. Rogers et al., 2012. With the involvement of smart concepts in sustainable development, environmental, sociological, and economic concerns are increasingly considered in the quest for a higher standard of living. Gehan, 2001. These factors are linked, and they are all necessary for individual and social well-being. In a specific system, such as a building, smart refers to an entity with sophisticated control systems and technologies that enable interconnected operability and the capacity to respond quickly to external and internal communications. Pipatana Samporn et al., 2009. Many studies have discussed smart concepts, e.g., smart grid, smart buildings, and smart cities, and their interactions. Smart grid ideas advocate using modern information and communication technology, ICT, infrastructure to enhance grid and grid edge, for example, consumer monitoring and control and communication between them. Good et al., 2017. Definitions of smart buildings. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 176. have been proposed and constantly evolved. Since 1980, a structure's smartness is defined as a space with complete control over its surroundings. Wang et al., 2005. Frequent discussions exist among researchers, industry experts, communities, and higher government level officials concerning smart buildings and smart cities, since buildings and infrastructure must be developed and run in line with smart city features. Apanavasin et al., 2020. Irrespective of what tools and applications are involved, the smart city definition is inclusive enough to cover all important initiatives. As an interdisciplinary topic, it must face increasing problems from various urban dimensions. Damery and Rosenthal. Sabru, 2014. The term smart city refers to using various information technologies or innovative concepts to connect and integrate urban systems and services to improve resource utilization, efficiency, optimize urban management and sources, and improve citizens' quality of life. Guo et al., 2016. A smart city connects various urban infrastructures to achieve urban intelligence. Harrison et al., 2010. This topic is a cutting-edge area for theoretical study and actual applications. Further research into smart cities is still developing. Damery and Rosenthal. Sabru, 2014. Based on smart city research, new academic and industrial domains are emerging that mix technology and services, including policy discussions from other disciplines. Lim et al., 2021. However, understanding and describing smart cities from several viewpoints is difficult, given the extensive use of this idea in various fields, for example, urban planning and administration. Future studies should discuss smart city initiatives in more detail. Researchers agree that it is critical to interact with the past while considering the future. Sandford, 2019. Developments in heritage smartness are still novel, and some researchers have contributed to comprehensive heritage management and conservation through the digital domain. However, there are only a few review articles on smart heritage and sustainable development that exhibits lag in understanding and developing strategies for smart architectural heritage. This article reviews literature relevant to smart heritage with a sustainable background. It aims to offer new insights into the architectural domain, to develop a framework guiding implementations and applications. This paper does not review all academic publications on the topic but integrates views to construct novel interpretations. Section 2 describes the review methodology, including data collection and analysis methods. In Section 3, a review of smart heritage is conducted corresponding to different features. Section 4 categorizes the key outcomes from selected publications and discusses the contributions of this review. Likewise, Section 5 presents the concluding remarks. 2. Methods and materials. A literature review is a method of gathering and analyzing previous studies. Baumeister and Leary. 1997, Snyder, 2019, Tranfield et al., 2003. They Literature associated with smart heritage covers various disciplines, which requires a creative data collection method. According to Snyder, 2019, the integrative review approach can be adopted to understand smart heritage development. The authors reviewed literature from cultural heritage to different heritages, extending into semantics, such as heritage monitoring, management, presentation, digitization, and visualization. The article selection procedure cited by Tan et al. 2021 is specialized to correspond to the research aim of this study, and the review workflow is shown in Figure 1. Keyword searches in Science Direct and Scopus for Smart Heritage, Smart Cultural Heritage, and Sustainability support this review. In addition, highly relevant paper insights from selected articles are reviewed. This study untangles and structures pre-existing knowledge based on 44 highly relevant articles to smart heritage. The initial search included queries using a combination of smart heritage with sustainability. Key concepts in cultural heritage are reviewed at the start to support keyword identification and narrow down the research scope. The keywords smart cultural heritage and sustainability are then adopted to conduct a review of publications on heritage, smartness and cultural heritage domains. 2. Rules are set to filter the target literature. A. Identify cultural heritage intangible domains, which excludes literature from intangible cultural heritage, and B. Adopt concepts of smartness to promote architectural heritage protection and sustainable development. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 177. Figure 1. Article selection process. Thematic analysis is used initially to identify common themes and ideas in data analysis. The authors use research topics and contributions from the selected articles to classify this review into 3 phases: 1. Early discussion, 2. Detailed discussion, and 3. Particular discussions within specific discourse. Collected data were initially imported into Microsoft Excel to determine the general features of each document. After reviewing all selected publications, content analysis is conducted to identify the contributions from each study. The steps are as follows: 1. Summarizing contributions based on the authors and years of publication. 2. Categorizing them based on each contribution, and 3. Identifying critical concepts mentioned in the article and generating themes. Acknowledgment, 2022. 3. Results. 3.1 Cultural heritage, key concepts. Cultural heritage includes tangible and intangible assets with historical, artistic, scientific, and cultural value. Ahmed, 2006. Vecco, 2010. It generally incorporates architectural works, works of monumental sculpture and paintings, archaeological sites, literary masterpieces, ethnological treasures, oral traditions, and unwritten languages. Bedate et al., 2004, Ferretti et al., 2014. Harvey, 1997. Cultural heritage is a crucial bridge linking humanity's past, present, and future. Over the years, its definition has been considered a dynamic category within constant social and cultural evolution, Leeds et al., 2020. In modern theory, cultural heritage definitions are constantly updated and reiterated, the whole is the result of continuous historical transformation and progress, Selim et al., 2022. The UNESCO World Heritage 1972 Convention recognizes cultural heritage monuments, groupings of structures and sites as having extraordinary historical, artistic, or scientific value, clear, 1996. Cultural heritage is essential to sustainable urban development in the new urban agenda. For instance, it can be used to protect and promote cultural infrastructures and sites, museums, indigenous cultures and languages, traditional knowledge, and arts in cities and human settlements, Agenda, 2016. Conflicts between preservation and development continue in urban development. Traditional urban elements adapt to contemporary trends by incorporating tools and techniques, enabling them to become smart. Kaukopoulos et al., 2017. Heritage is an integral part of them. 3.2 Early research into smart heritage. When smart techniques are adopted in heritage fields, well-rounded and systematic conservation and management processes are involved. The exploration of new modes in different heritage discourses widens the knowledge of smart heritage. According to Adrian and Kernia 2020, InTouch Heritage Academy introduced Smart Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 178. Concepts into the heritage field in 2007 by Addressing the Challenges of Cultural Heritage. Conservation based on ICT. Based on keyword searches in this study, discussions around smart heritage started in digital cultural heritage when Maus Takas and Soveras, 2010, proposed a virtual reality (VR) framework for heritage modeling and interactive simulation. In addition, Behrman, 2011, mentioned smart objects in the museum discourse and highlighted that cutting-edge techniques help visitors have a more enjoyable visit. Tofek and Mohammed, 2013, suggested the use of smart aspects in heritage protection, and how integrating emerging construction and heritage environments needs to rely on measurable technologies and methods to meet the calls for sustainability. Hussain et al., 2013, indicated that integrated multidisciplinary information, for instance, geographic data, using smart tools not only documents the past and current status of heritage sites but also supports decision making in the future. They considered how smartness may benefit sustainable development plans by reviewing and discussing the ways combined technology applications can potentially model a real web-based heritage scene. Thwaites, 2013, discussed digital heritage and what occurs when heritage contents are digitized, pointing out that smart heritage and cultural Futures refer to software that combines pictures and sound collected at heritage sites. Tools, such as animation and film, should be used to build complete hybrid virtual reality environments as far as possible. Smart heritage research is promising because it aims to produce new experiences and ensures that the cultural future is intact. Thwaites. 2013. Ken Durden, 2013, used captured images combined with methods, such as narrative techniques, to create immersive panoramas of the Dunhuang Majao cave site with rich details, which involved tourists and created an interactive scene. History and culture can be inherited. Chianese and Picciali, 2014. Developed an Internet of Things, IoT, architecture that assisted the creation of a static cultural environment. Even though they did not directly mention smart heritage, they stated that modern technology, such as sensors, sought to turn cultural items into smart objects that could communicate with one another, visitors, and networks. This acquired characteristic is critical for cultural spaces. Smartness. By adopting the IoT paradigm, consisting of sensor nodes capable of transforming cultural spaces, stakeholders can develop strategies to support heritage smartness. Other technology paths suggest a different direction for heritage smartness. Gehan, 2014, has discussed the current state of augmented reality, AR, in cultural heritage. A simulated case study in a historical neighborhood proves that AR on mobile devices can dynamically offer smart and interactive solutions for the cultural heritage conservation scenario. Likewise, Chung et al. 2015 investigated how AR affects people's desire to visit historical places. Besides IoT, AR brings opportunities for heritage digitization and visualization. Selim et al. 2021, but smart heritage might consist of more than a single context or application. Chianese et al. 2015 used IoT to address complex links between transmitting historical knowledge and visitors' experiences in heritage environments through smart design. The development of smart objects supported the progress of this research with the aim of stimulating visitors' interest and enjoyment. 3.3 Technologies for developing smart heritage. Technologies play a crucial role in smart heritage development, highlighting the latter's potential to turn cultural institutions like heritage sites into current assets. Selim et al. 2022. Della Corte et al. 2017, described smart concepts being applied to museums and historical sites with smartness entailing ICT, as evidenced by deploying AR and 3D modeling during producing phases of cultural materials and using cloud environments during modeling and display phases. Della Corte et al. 2017. According to this study, smart heritage can be defined as an ICT-enabled virtual environment that satisfies the requirements of different stakeholders, such as online heritage touring, heritage protection, and sustainable cultural promotion. Borda and Bowen, 2017, assessed cultural heritage in several cases across different countries using smart platforms and visualization technologies. They found that the cities and cultural heritage's smartness needs require contextualized services, which can be made feasible by a shared set of fundamental technologies. With the implementation of smart advancements, those technologies are becoming pervasive and inextricably linked. Borda and Bowen. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 179. Introduced visualization technologies, such as simple infographics for 3D modeling and AR, combined with technologies, such as IoT, which were applied to every project. However, only some of the projects can be considered an achievement of smart heritage. For example, by aiming the device's camera toward the object, an AR application named Skin and Bones created a virtual environment on real objects in the Smithsonian National Museum of Natural History in the United States. Visitors could use an app to test their natural history knowledge by participating in activities, such as identifying a bat by its characteristic sound. The app is available on mobile devices so that visitors can visit exhibitions virtually. Borda and Bowen, 2017. According to Chianese and Picciali, 2016, technological involvement is insufficient to deem a place smart because smartness must be developed by a collection of applications and services with integrated use of shared and created data. To that end, smart heritage should consider the extensive use of various cutting-edge technologies to achieve smartness across multiple aspects and serve stakeholders. Riganti, 2017, attempted to construct a smart heritage agenda for sustainable and inclusive communities with a model based on a previously established smart environment, based on a geographic information system, GIS, to support decision-making in long-term cultural heritage management. Riganti's core point was that it is vital to comprehend the value placed on heritage products by diverse stakeholders, particularly local people, to develop full and deep management of cultural heritage. She further suggested that the environment can address most cultural preservation problems. Smart solutions, ranging from customized apps to sensors that provide real-time data, should be included in these categories: 1. A user-friendly platform, 2. An open heritage mapping platform, and 3. A platform with a basic set of features, such as high-definition 3D visualization and real-time data. Riganti, 2017. Wang et al. 2018, employed a device-to-device, D2D, communication method based on 5G mobile networks to develop conservation and management networks to address issues of low transmission rates and expandability between IoT and wireless sensor network, WSN. Compared with the study by Chu et al. 2015, and reviewed in the following section, Wang's strategy brings attention to museum digitization and visualization, using Smart cultural heritage and emphasizing how smart city and heritage disciplines strengthened their practical convergence and materialized smart heritage itself. In the other domain, Gehan, 2018. Overviewed tools and strategies for collecting geographical data for modeling heritage buildings. According to the study, the concept of smart heritage could be described as achieving more rational decision-making in heritage building, conservation with the involvement of spatial data and building information modeling. BIM. The initial stage in the documentation and preservation of historic structures is frequently digitized. However, it is an insufficient basis for making educated decisions about the usage and maintenance of heritage structures. Gehan, 2018. According to the author, complex tasks, for example, structural health monitoring and assessing environmental impacts like weathering, need to combine enough semantic information from geographical data in historical records and topological relationships into the BIM. A historic BIM streamlines the ongoing documentation of all preservation and restoration efforts and the administration and interchange of building data. In contrast to Gehan, 2018, Pocobelli et al. 2018. Reviewed BIM applications in historic building conservation projects, using BIM technology to model building components as smart objects with numerical parameters defining the parametric information of the components, e.g., dimensions, and embedding other types of information, such as building materials and attributes. Pocobelli et al. 2018, emphasized giving smartness to architectural components and focusing more on the microscopic level. Anwar, 2019. Elaborated on how people place linkages might be used to determine a cultural heritage area's smart implication. The smart city trend has led to using smart technology in heritage conservation by employing tools such as photogrammetry, reality-based 3D documentation, and permanent digitization. Smart approaches of archiving and genuine digital surrogates represent two heritage restoration strategies. Social networking, 3D visualization, and VR technologies are among the interactive features that deem the physicality of a heritage virtual. Virtual heritage has thus become a popular concept in culture and history preservation. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 180. Conservation and Interpretation. Abdelmanem et al. 2017. Suwardi et al. 2022, discussed the creation of a prototype for a multipurpose land management system for an urban cultural heritage region. The first step would be creating a 3D map for documentation of cultural heritage locations. This step would further support heritage protection. In addition, using laser scanners and photogrammetry, a model of a historic building could be visualized at various levels of detail and used in heritage building information modeling, HBIM, for building. Maintenance. 3D models can be saved as a 3D GIS, BIM, or a combination of the two, the so-called GeoBIM, based on data from the mapping process. Constructing a multipurpose land administration system. Prototype for the Cultural Heritage Region. Contributed to Suwardy's research, and this system included many advantages, including area planning, monitoring, and management. Metro et.al. 2022, drew on cutting-edge IoT tools to empower smart heritage ideas with a proposed approach that was autonomous, efficient, and non-intrusive. Their article represented using advanced technology to bring smartness into heritage, using smart tag devices to achieve low power consumption and long operational life. The data collected deviated little from the weather station, Metro et.al. 2022. However, one of the disadvantages was that the smart tags functionality was limited to the sensor monitor level. In terms of a comprehensive system, the smart tag needed to be considered further in terms of giving heritage a deeper level of smartness. 3.4 Smart Heritage Implementations and Applications. Many scholars have focused on developing paths and serving scenarios of smart heritage. Chu et al. 2015, proposed a novel service system named One Platform 3 Systems to address challenges in archaeological site data analysis and site management operations. It consisted of an online-offline on-site service system and a digital explanation system, also called a smart heritage management system. The presented platform achieved bidirectional engagement between heritage site management units and tourists, with visitors able to benefit from explanation and illustration of the site's cultural and economic values. Based on this study, smart heritage in the archaeological domain can be understood as a comprehensive system capable of operating and managing heritage data and providing heritage presentation. Picciali and Chianesi, 2018, attempted to recognize the connections between history and smart technology, characterizing the smart cultural environment as a new idea that blends objects, sensors, services, and apps into cultural sites, such as museums, monuments, and exhibitions. Vasilakis et al. 2018, developed a smart method capable of achieving specific heritage displays from an enlarged cultural collection database, controlled by users' data. Compared to Picciali and Chianesi, who highlighted the originality and connectivity of cultural objects, Vasilakis et al. Focused on smart technologies, as they fulfill significant roles in heritage presentation and communication. Ardito et al. 2018, offered a strategy for end-user development for integrating smart device services. 14 professional guides from various cultural heritage sites in southern Italy were involved in this study. Using a visual composition paradigm, end-user approaches provided opportunities to customize systems for diverse users' situational demands. Balducci et al. 2020, considered visitors' interests and feelings by improving smart Interactive experiences, focusing on an interactive paradigm based on IoT technologies for managers and operators to synchronize different smart objects into a specific environment to satisfy visitors' needs. It is worth noting that Ardito et al. 2018 aimed to develop interactive methods in which end users without programming abilities might have smart experiences through the interoperable management of smart objects. Some resources, such as smart objects or web services, were required for the smart experience, but Balducci et al. 2020 focused more on the visitor's interactive experiences. Heritage smartness should become a system aggregating advanced technological tools and satisfying the stakeholders. Therefore, holistic considerations in the technological level of platforms and serving objectives are crucial to developing a smart heritage. It is also a beneficial exploration of organically combining art, technology, and humanities. According to Larario and Varasano, 2020, smartness in architectural heritage should be regarded as a holistic approach that not only brings the systematic opportunity with Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 181. Monitoring and protecting function into heritage but also links heritage with urban data processing, environmental monitoring, economic growth, and public services. Cultural heritage smartness is highly likely to affect the promotion of social cohesion and push innovation, especially when combined with smart city initiatives. Borda and Bowen, 2017. Vizen and Syria, 2020, provided a functional system for the digital transformation of cultural heritage and actual procedures for realizing virtual displays. Collaborations with IoT and mobile technologies are indispensable when looking to facilitate smart cultural heritage development. In parallel, digitalization efforts efficiently disseminate key historical data sources and help to preserve the past. Digital cultural heritage is brought to life through innovative visual analysis, interpretation, and engagement methods. Cultural factors influence the progression towards more sustainable options and acceptance and implementation of circular economy ideas. Stanojev and Gustafsson, 2021. Different urban development stakeholders notice clear economic factors in future sustainable development. Therefore, smartness in cultural heritage should not be neglected. According to Borda and Bowen, 2017, integrating heritage and advanced technologies benefits the economy and culture by attracting more tourists, protecting heritage, and creating more jobs. Carrying out theoretical and practical innovation in heritage protection and management is vital to building a modern public cultural service system. 3.5 Smart Heritage within Smart Cities. With a more detailed and profound discussion of smart heritage in different fields and layers. As the previous authors, Borda and Bowen, 2017. Sindhu and Rishmai, 2020, mentioned, heritage smartness is directly or indirectly affected by the development of smart cities, and these two concepts tend to be inseparable and are worth discussing together. Cultural heritage is an invaluable global resource, and its relevance to a smart city grows as it is integrated into the digital ecosystem, especially when considering urban history and civilization in the construction of the system. Amato et al., 2013. Sindhu and Rishmai, 2020, stated that cultural infrastructure, including notable heritage structures, is an essential feature of cities, which should be included in smart city programs, and that smart city applications can help with heritage monitoring and maintenance. Angelado et al., 2017, discovered that cultural heritage management could be implemented through many smart city strategic areas, reflecting various points of view and supporting several aims. The authors found that smart city approaches could strategically underpin smartness. They added that considerations of specific tools and applications for meeting urban developing trends, such as livability and sustainability, can support the objectives of cultural heritage preservation and promotion in the context of a smart city. 3 years later, Angelidou and Stylianides, 2020, revisited the progress achieved, focusing on whether the inadequate substantiation of heritage in smart city policies mentioned in 2017 had been improved. Tarragona, Spain, Budapest, Hungary, and Karlsruhe, Germany, were smart city examples chosen in this study, which found that cultural heritage smartness was not addressed sufficiently within these smart city initiatives. Their conclusion can be regarded as an interpretation of smart heritage, highlighting adopting sensors and other advanced hardware and software as the way to achieve the following goals: 1. Improving visitors' experiences, 2. Raising public awareness of a specific cultural heritage, 3. Preserving cultural heritage, and 4. Better managing conditions and utilities in heritage sites. The importance of cultural heritage in smart urban initiatives is rising, driving the emergence of a trend that links cultural heritage with sustainable urban development. Mar et al., 2018, introduced an application in which different stakeholders of historical sites could share a visit itinerary with detailed real-time information tailored to their interests. The authors committed themselves to extending a smart city idea into a smart historical city project, SH City, which took on an unprecedented challenge of producing an open-source tool to connect urban heritage centers. The SH City was characterized as a system that processes information from urban 3D maps and data from sensor networks to monitor various heritage sites. This study combined digital sensors with historical sites to collect data and made it accessible to management and tourists, presenting a great example of achieving smart heritage. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 182. According to Alam and Newman, 2018. Smart cities often reflect the ICT industry. ignoring the cultural and historical characteristics that certain cities have inherited. Neve, 2018, indicated that prevalent notions about the nature of cities, smartness, cultural heritage, and the popular topic of smart cities do not appear to be a good fit. Neve emphasized the critical need for multidisciplinary research projects, examining the interrelationships between all city aspects, placing heritage at the city's core. Smart heritage should be understood as a co-evolving assemblage of the built environment and people heritages. Smartness research is critical for sustainable urban development. Adrian and Kurniawan, 2020, discussed whether smart heritage were relevant to cultural sustainability when smart city development became a hot topic in the 2000s. According to previous research, e.g. Chianese and Picciali, 2014, Della Corte et al. 2017, as people moved toward an ICT-equipped smart era, Intouch developed solutions to support visitors' experiences, archaeological work, and management of cultural heritage based on shared interests and decisions that engaged people and experts and aimed at developing heritage conservation, management, archaeology, interpretation, and experience. However, Adrian and Kurniawan, 2020, indicated that smart heritage was still novel and yet to be completely implemented in any city. The role of smart heritage development is to help in decision-making in cultural heritage protection and create new prospects for economic growth while satisfying the public need for knowing, researching, and preserving. Adrian and Kurniawan, 2020. Brusaporsi, 2020, analyzed tangible heritage definitions, discussed difficulties in heritage digitization, and underlined new linkages between actual dimensions and digital heritage as a vital element of cities. Architectural heritage studies have exceeded mere modeling and visualization, in contrast to previous outcomes developed by other scholars. Brusaporsi did not regard smart heritage and smart cities as two entirely different concepts. Instead, the smart city approach was directly adopted to process a multitude of inputs, stakeholders, and outputs in the urban heritage context. The author employed a comprehensive smart city approach to defining smart heritage, which included seamless interactions between smart technology and heritage in various ways. Brusaporsi mentioned that the IST's involvement in cultural heritage promotes a cultural shift, resulting in a sustainable inheritance of culture and history in smart city contexts. With AR and IoT, information matches real objects with displays on screens, such as VR goggles, and heritage becomes more than mere digital objects. They transform into cyber objects. Although the author did not detail how smart heritage might promote sustainability, this study broke traditional boundaries between smart heritage and smart cities, tending to integrate architectural heritage databases and smart city construction. Gandhi et al. 2021, studied the missing links between heritage site protection and smart city development planning by identifying Museums and heritage sites in Pune, India, as cultural markers and using GIs to examine metro development plans to see if the present geography of museums and historical sites needed to be aligned with Pune's smart city objectives. This study demonstrated that urban upgrades and modernization cause conflicts in preserving crucial historical and cultural sites. Heritage needs to update in real time to cope with urban changes. When cultural heritage evolves, Sneeze et al. 2021 pointed out that some complicated issues, such as innovative procedures and heritage digitalization, should be contemplated during the transformation from traditional to smart initiatives. Smart city solutions offer new ways to manage and promote immovable physical facilities, such as historic buildings and monuments. This study highlights the role of stakeholder collaboration in cultural heritage management when making an old town smart. The authors stated that it was feasible to address and include a variety of stakeholders' interests by using a participative, interactive digital platform that manages and transmits cultural heritage content. Min et al. 2021 used smart cultural heritage while developing heritage site management in France. By using smart technology, they found that smart heritage could help maintain heritage sites' tangible and intangible characteristics. It points out that to make heritage smart, an urban cultural heritage framework is required. The framework should consist of cultural indicators regarded as vital components of community infrastructure. To achieve the goal of smart governance, smart heritage indicators must be standardized, consistent, aggregated. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 183. And updated throughout time and space. Highlighting cultural and architectural elements. This study team devised a smart cultural heritage management strategy made up of 5 steps to becoming a smart community. 1. Data supply management and smart survey program. 2. Smart classification criteria. 3. Heritage management regulations. 4. Community management, and 5. Enhanced heritage understanding. Therefore, these efforts towards cultural heritage must fulfill the following criteria. 1. Long-term development of activities to give heritage preservation information. 2. Smart and receptive administration of heritage and the community. And 3. Restructuring citizen authority interactions with transparency and clarity. Min et al. 2021. 4. Discussions. 4.1 Contribution classification of reviewed articles. Based on articles searched and reviewed in this study, the critical contributions from each article are categorized into 5 parts. Digital heritage was increasingly discussed by researchers, e.g., Moustakas and Tsovaras. 2010, when a hot discussion wave rolled up in smart heritage. The worth noting contributions using different technologies are presented in Table 1. The authors of this article believe that heritage digitization is a foundation for developing smart heritage. Table 1. Contributions to digital heritage. Authors' year contributions. Adopted technologies. Moustakas and Soveres. 2010. VR Framework for Heritage Modeling and Interactive Simulation. VR. Hussein et al. 2013. Integrated multidisciplinary information not only documents the past and current status of heritage sites but also supports decision-making in the future. Geographic Technology. Thwaites 2013. Software that combines pictures and sound collected at heritage sites. Tools such as animation and films. Kendurden 2013. Captured images are combined with narrative techniques to create immersive panoramas of Dunhuang Majao cave site with rich details. AR. Chung et al. 2015. Digitization affects people's desire to visit historical places. AR. Abdelmanem et al. 2017. Virtual heritage has become a popular concept in culture and history preservation, conservation, and interpretation. 3D visualization and VR. Wang et al. 2018. The proposed strategy brings interaction into museum digitization and visualization. Device-to-device communication method based on 5G mobile networks, IoT, and WSN. Suwardi et al. 2022. 3D map for documentation of the cultural heritage. Location would further support heritage protection. 3D GIs, HBIM. Following digital heritage, some researchers are devoted to bringing smart ideas into different fields of cultural heritage. These are summarized as paths and methods of making heritage smart in different layers and scales, as shown in Table 2. Tools adopted in the selected articles are presented in Figure 2. This chart shows that more tools, e.g., AR, 3D modeling, and network, are involved in heritage conservation and documentation as smart heritage discussions increase. Some core theories, Table 3, contributed by scholars, are regarded as significant guidance in the smart heritage discourse. A solid theoretical foundation is indispensable to support the discussion and construction of smart heritage. Smart heritage ideas present more interactive and collaborative technologies in academic and application fields of heritage for various. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 184. Purposes, including protection, management, education, and inheritance. Table 2. Key contributions in smart heritage developing paths and methods. Authors' year key contributions. Adopted technologies/tools. Chianese and Picciali. 2014. The employment of modern technology sought to turn cultural things into smart objects that can now communicate with one another, visitors, and the network. IoT paradigm consisting of sensor nodes. Gehan 2014. AR on mobile devices dynamically offers smart and interactive solutions in the cultural heritage conservation scenario. AR and mobile devices. Gehan ETL 2015. Address the complex link between transmitting historical knowledge and visitors' experiences in heritage environments through smart design, IoT and smart objects. Pocobelli et al. 2018 make architectural components smart. BIM. Ardito et al. 2018. Develop interactive methods in which end users without programming abilities can have smart experiences through the management of interoperable smart objects. Smart objects or web services are required for the smart experience. MAR et al. 2018. Combine digital sensors with historic sites to collect data and make it accessible to managers and tourists. Photogrammetry, 3D documentation. ANWR 2019. People-place linkages might be used to determine a cultural heritage area's smart implication. Photogrammetry, reality-based 3D documentation, and permanent digitization. Metro et al. 2022. The use of advanced technology to bring smartness into heritage. IoT. Figure 2. Key methods or tools for developing smart heritage mentioned times in the selected articles in each year. 1. 2. 1. 2. 1. 1. 1. 3. 1. 2. 1. 3. 2. 1. 1. 2. 1. 2. 1. 1. 1. 2. 2. 2. 2010. 2011. 2013. 2014. 2015. 2016. 2017. 2018. 2019. 2020. 2021. 2022. Tools mentioned times in the selected articles in each year. Year. ICT IoT AR/VR BIM, 3D modeling, /GIS Sensors Network Platform. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 185. Table 3. Core theories contributed by scholars. Authors year mentioned key theories. Behrman 2011. Smart objects in the museum help visitors have a more enjoyable visit. Gehan and Picciali 2016. The simple involvement of technologies is insufficient to define a place as smart. Riganti 2017. Smart solutions should be included in these categories. 1. A user-friendly platform, 2. An open heritage mapping platform, and 3. Platform with a basic set of features, such as high-definition 3D visualization and real-time data. Borda and Bowen 2017. The smartness needs of cities and cultural heritages require the achievement of contextualized services, which can be made feasible by a shared set of fundamental technologies. Picciali and Gehan 2018. Smart Cultural Environment as a New Idea that Blends Objects, Sensors, Services, and Apps into Cultural Sites, such as museums, monuments, and exhibitions. Vasilakis et al. 2018. Smart technologies play significant roles in heritage presentation and communication. Alam and Newman. 2018. Smart cities often reflect the ICT industry, ignoring the cultural and historical characteristics that certain cities have inherited. Adrian and Kurniawan. 2020. Smart heritage development is to help decision-making in cultural heritage protection and create new prospects for economic growth, while satisfying public needs of knowing, researching, and preserving. Visan and Syria 2020. Collaborations with IoT and mobile technologies are indispensable when looking to facilitate smart cultural heritage development, and digitalization efforts efficiently disseminate key historical data sources and help preserve the past. Selim et al. 2021. AR brings opportunities for heritage digitization and visualization. Stanojev and Gustafsson. 2021. Cultural factors influence the progression toward more sustainable options and acceptance and implementation of circular economy ideas. Gandhi et al. 2021. Urban upgrades and modernization are causing conflicts in preserving crucial historical and cultural sites. The more advanced technologies are applied in heritage and urban protection and regeneration, the closer the connection between smart heritage and smart cities. A great deal of previous work corroborates this finding. For example, various ICT tools and knowledge across different heritage areas can extend smart city ideas into a smart heritage concept. Mar et al. 2018. Table 4 lists the crucial theories that involve smart heritage and smart cities based on this review. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 186. Table 4. Key theories involve smart heritage and smart cities. Authors year key theories between smart heritage and smart cities. Amato et al. 2013. Cultural heritage is an invaluable global resource, and its relevance with a smart city grows as it is integrated into the digital ecosystem. Angelado et al. 2017. Cultural heritage management can be implemented through many smart city strategic areas. Sindhu and Rishmai 2020. Cultural infrastructure, including notable heritage structures, is an essential feature of cities, which should be included in smart city programs. Brusaporsi 2020. The smart city approach is directly adopted to process various inputs, stakeholders, and outputs in urban heritage aspects. Sneeze et al. 2021. Smart city solutions offer new ways to manage and promote immovable physical facilities, such as historic buildings and monuments. Smart cities are inextricably linked when defining smart heritage, regardless of the perspective. In each heritage domain, smart heritage has its respective features and definitions. For example, in an exhibition, a virtual cultural exhibiting space is developed with sensors, networks, and applications to provide different services. In the historic building domain, smart heritage regulates and accesses data connected to historic buildings and their surrounding regions, preventing existing danger factors. Based on this review, the interpretations of smart heritage from reviewed articles are summarized in Table 5. Following this, a timeline of milestones in defining and developing smart heritage is presented in Figure 3. Smart heritage is still a novel concept. The popularity of this topic began about 10 years ago, covering fields ranging from archaeology, tourism, and architecture to information, technology, and the Internet. Research from 2013 to the present significantly defined smart heritage and formulated its indicators. Following this review, the authors of this article believe that smart heritage should be developed in smart cities, and they can be regarded as two interacting concepts. Developing indicators to define smart heritage seems a necessary step as a broad concept. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 187. Table 5. Interpretations of Smart Heritage from Reviewed Articles. Authors Year Smart Heritage Interpretations. Chu et al. 2015. Smart heritage in the archaeological domain can be understood as a comprehensive system capable of operating and managing heritage data and providing heritage presentation. Della Corte et al. 2016. A virtual environment established by employing ICT to satisfy requirements of different stakeholders, such as online heritage, touring, heritage protection, and sustainable cultural promotion. Koshalha M. 2018. Smart heritage can be described as achieving more rational decision-making in heritage building conservation with the involvement of spatial data and BIM. Nave 2018. Placing the idea of heritage at the city's core, smart heritage should be understood as a co-evolving assemblage of built environment and people, and heritage smartness research is claimed to be critical for sustainable urban development. Balducci et al. 2020. Heritage smartness should become a system aggregating advanced technological tools and satisfying the stakeholders. Larario and Varasano. 2020. Smart architectural heritage should not only bring systematic opportunities with monitoring and protecting function into heritage, but also link heritage with urban data processing, environmental monitoring, economic growth, and public services. Angeladu and Stylianides. 2020. Smart heritage to achieve the following various goals. 1. Improving visitors' experiences. 2. Raising public awareness of a specific cultural heritage. 3. Preserving cultural heritage. And 4. Better managing conditions and utilities in heritage sites. Min et al. 2021. Smart cultural heritage management strategies are listed as follows. Data supply management and smart survey program. 2. Smart classification criteria. 3. Heritage management regulations. 4. Community management. 5. Enhanced heritage understanding. Figure 3. Timeline of milestones in defining and developing smart heritage. 4.2 Smart heritage indicators and novel Understanding. According to the above-mentioned tables and figures, based on standard systems developed by Riganti, 2017, Adrian and Kurniawan, 2020, and Min et al. 2021, Smart Heritage from Theory to Tailored Application and Service Objectives should be incorporated into the following indicators. Table 6. Table 6. Indicators and Effect Factors. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 188. Indicators Effect Factors. Heritage digitization. Cost. Technology. A user-friendly platform. Data collection. Data integration. Data analysis. Service objectives. Requirements. Benefits. Application. Optimization. Users' feedback. New reuse. Finally, based on this review, the framework for developing smart heritage should comprise the following stages. Heritage digitization and visualization using technologies, such as photogrammetry and 3D scanning, to form digital base plates. With presentation through BIM, GIS, or both, or other types of models, a user-friendly platform. Construction through adopting techniques, such as WSN and IoT, to generate real-time interactive data. Identification of service objectives to develop different applications with the help of heritage models and data. For example, developing an app to enable virtual touring on users' smartphones and establishing a safety monitoring system for heritage buildings. Collection of user feedback to enhance and optimize applications. The authors of this article provide a new understanding of smart architectural heritage as architectural heritage is visualized through 3D modeling technologies and connected with numerous urban components through techniques like IoT to reach different goals in sustainability. These goals include heritage modeling for protection, developing virtual museums for touring, educating the following generations in history and structural health, monitoring of historic buildings. 5. Conclusions. This article conducts a holistic review of smart heritage to address its definitions within sustainable development and present its definition in the architectural field. Meanwhile, a few review articles cover smart heritage in academia, which provides a reference for scholars from different disciplines to interpret and develop heritage smartness. Smart heritage as a concept broadly covers various aspects of heritage and technology. Digitization and visualization support informative and interpretive applications in different contexts. Different applications follow in the footsteps of earlier discussions and extend to detailed research by adopting more advanced technology. As a broad concept, smart heritage definitions should be refined into different sub-research areas, as each represents a different application and contribution, even though they are interoperable. This article presents indicators for smart heritage definition and a framework for its development, including criteria and technology adoption for different purposes. They are novel outcomes which pave the way for more relevant Studies. As another novelty, smart architectural heritage from a new perspective is interpreted as using technologies, such as 3D modeling and IoT, to manage architectural heritage to satisfy various requirements, including documentation, virtual tour, and adaptive reuse. Smart city solutions apply to heritage smartness, and smart heritage development contributes to the progress of smart cities. Therefore, the concept of a smart city should also come into play regarding smart heritage. The authors believe that the ways to make historic buildings smart within the smart city context will come to the fore in future research, bridging smart cities and heritage fields. This review has some limitations. 1. The search is limited to articles in English, and 2. Phrases used in different studies may not be covered by the keywords used for the search. Further research is needed to consider more influence. Nevertheless, the authors of this article contend that a continued evolution exists in standard system establishment and further expansion in smart heritage understanding. Detailed subdivisions might include integration between different disciplines, approaches considering citizens and communities, deepening sustainable future urban development, and optimizing smart heritage outcomes and their practical applications. Acknowledgement. This research did not receive any specific grant from funding agencies in the public, commercial, or not-for-profit sectors. Conflicts of interest. The author, declare, that there is no conflict of interest. Data availability statement. The original contributions presented in the study are included in the article/supplementary. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 189. Material. Further inquiries can be directed to the corresponding author/s. Ethics statements. Studies involving animal subjects, no animal studies are presented in this manuscript. Studies involving human subjects, no human studies are presented in this manuscript. Inclusion of identifiable human data, no. Potentially identifiable human images or data is presented in this study. Credit author statement. Conceptualization, HS, GS. Data curation, HS, GS. Formal analysis, HS, GS. Investigation, HS. Methodology, HS, GS. Writing original draft, HS. Writing review and editing, HS, GS. All authors have read and agreed to the published version of the manuscript. References. Abdelmanem, M.G., Selim, G., and Mushadat, S. 2017. Virtual Platforms for Heritage Preservation in the Middle East, The Case of Medieval Cairo. International Journal of Architectural Research, ArchNet IJAR, 11, 3, 28-41. https://doi.org/http://10.26687/archnet. IJAR.v11 I3.1404. Adrian, S.M., and Kurniawan, K.R. 2020. Smart Heritage. Media for realizing cultural heritage conservation in the Smart City Era. IOP Conference Series. Earth and Environmental Science, 452, 1. https://doi.org/https://doi10.1088/1755 1315/452/1/0120058 Agenda, NU 2016 Habitat 3 UN 2016-74 Retrieved from http://unhabitat.org.ir/wp-. Content/uploads/2016/12/NUASEP 2016.pdf. Ahmed, Y. 2006. The Scope and Definitions of Heritage. From Tangible to Intangible. International Journal of Heritage Studies, IJHS, 12, 3, 292-300. https://doi.org/https://doi.org/10.1080/135272506000604. 639. Akshurk, G. 2022. A Systematic Overview of the Barriers to Building Climate Adaptation of Cultural and Natural Heritage Sites in Polar Regions. Environmental Science and Policy, 136, 19-32. https://doi.org/https://doi.org/10.1016/j.npsci.2022.05.0. 16. Z. and Newman, P. 2018. Redefining the Smart City, Culture, Metabolism, and Governance. Smart Cities. 1, 4-25. https://doi.org/https://doi.org/10.3390/Smart Cities 101000. 2. Amato, F. Chianese, A. Mazzeo, A. Moscato, V. Picariello, A. and Picciali, F. 2013. The Talking Museum Project. Prostia Computer Science, 21, 114. 121. https://doi.org/https://doi.org/10.1016/j.prox.2013.09.0. 17. Angelidou, M. Caraceliou, E. Angelidou, T. and Stylianides, E. 2017. Cultural Heritage in Smart City Environments. The International Archives of the Photogrammetry, Remote Sensing and Spatial Information Sciences, Ottawa, Canada. http://dx.doi.org/10.5194/ISBRS-archives-x-lee-2-w5-27-. 2017. Angelidou, M. and Stylianides, E. 2020. Cultural Heritage in Smart City Environments, they update ISBRS Annals of the Photogrammetry, Remote Sensing and Spatial Information Sciences, Göttingen. https://doi.org/10.5194/ISBRS Annals v2-2020-957-2020. Anwar, WFF. 2019. The Implication of Smart Environment on Old Palembang Cultural Heritage. Places. IOP Conference Series. Earth and Environmental Science, 396, 1. https://doi.org/https://10.1088/1755 1315/396/1/0123031 Apanavicine, R., Vanegas, A., and Phokides, P.A. 2020. Smart Building Integration into a Smart City, ZBISC. Development of a new evaluation framework. Energies. 13, 9, 2190. https://doi.org/10.3390/n130921990. Ardito, C., Buono, P., De Solda, G., and Matera, M. 2018. From Smart Objects to Smart Experiences, an End-User Development Approach. International Journal of Human Computer Studies, 114, 51-68. https://doi.org/https://doi.org/10.1016/j.exp.2017.12.00. 2. Balducci, F., Buono, P., De Solda, G., Impedavo, D., and Picino, A. 2020. Improving Smart Interactive Experiences in Cultural Heritage through Pattern Recognition Techniques. Pattern Recognition Letters, 131. 142-149. https://doi.org/https://doi.org/10.1016/j.paytrack.2019.12.0. 11. Baumeister, R.F., and Leary, M.R. 1997. Writing Narrative. Literature Reviews. Review of General Psychology, 1, 3. 311-320 https://doi.org/https://doi.org/10.1037/1089 2680.1.3.311 Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022 PhD candidate Heng Song, Professor Dr. Gehan Selim 190. Behrman, D. 2011. Geo-Aware Digital Cultural Heritage. Museum Opportunities and Experiences. In Handbook of Research on Culturally Aware Information Technology. Perspectives and Models, pages 431-445. IGI Global. https://doi.org/https://doi.org/10.4018/978-1-61520-883. 8.ch019. Bedate, A., Herrero, L.C., and Sands, J.A. 2004. Economic Valuation of the Cultural Heritage, Application to 4 Case Studies in Spain. Journal of Cultural Heritage, 5, 1, 101. 111 https://doi.org/10.1016/j.culher.2003.04.002. Borda, A., and Bowen, J. 2017. Smart Cities and Cultural Heritage. A Review of Developments and Future Opportunities in EVA, BCS, http://dx.doi.org/10.14336/EWIC/EVA2017.2. Brusaporsi, S. 2020. Towards Smart Heritage, Cultural Challenges in Digital Built Heritage. In Applying Innovative Technologies in Heritage Science, pages 271. 296. IGI Global. https://doi.org/https/doi.org/10.4018/978-1-7998-2871. 6.ch013. Chianesi, A., and Picciali, F. 2014. Designing a Smart Museum, When Cultural Heritage Joins IoT 2014 8th International Conference on Next Generation Mobile Apps, Services, and Technologies. https://doi.org/10.1109/mast.2014.21. Chianesi, A., and Picciali, F. 2016. A Smart System to Manage the Context Evolution in the Cultural Heritage Domain. Computers and Electrical Engineering, 55, 27-38. https://doi.org/https://10.1016/j.compilesang.20. 16.02.008. Chianesi, A., Picciali, F., and Riccio, G. 2015. The Trust Project, Improving the Fruition of Historical Centers through Smart Objects. Prostia Computer Science, 63. 159-164. https://doi.org/https://doi.org/10.1016/j.prox.2015.08.3. 27. Chung, Han, H., and Jaun, Y. 2015. Tourist's Intention. To visit a destination, the role of augmented reality, AR. Application for a heritage site. Computers in Human Behavior, 50, 588-599. https://doi.org/https://doi.org/10.1016/j.chb.2015.02.068. Clear, H. 1996. The Concept of Outstanding Universal Value in the World Heritage Convention. Conservation and Management of Archaeological Sites, 1, 4, 227-233. https://doi.org/10.1179/13503967931394042. Demarai, R.P., and Rosenthal Sabru, C. 2014. Smart City and Value Creation. In R.P. Demarai and C. Rosenthal. Sabru, eds. Smart City, How to Create Public and Economic Value with High Technology in Urban Space. Pages 1-12. Springer International Publishing. https://doi.org/https://doi.org/10.1007/3-319-06160. 3. Deacon, E. 2001. Sustainable Development and Sustainable Transportation, Strategies for Economic Prosperity, Environmental Quality and Equity. UC. Berkeley, Institute of Urban and Regional Development. Retrieved from https://scholarship.org/uc/item/0m1047xc. Della Corte, V., Aria, M., and Delgadio, G. 2017. Smart. Open, User Innovation and Competitive Advantage, A. Model for Museums and Heritage Sites. Museum Management and Curatorship, 32, 1, 50-79. https://doi.org/https://doi.org/10.1080/0964775.2016.1. 247,380. Ferretti, V., Botero, M., and Mondini, G. 2014. Decision. Making in Cultural Heritage, an application of the multi-attribute value theory for the reuse of historical buildings. Journal of Cultural Heritage, 15, 6, 644-655. https://doi.org/10.1016/j.culher.2013.12.007. Gandhi, P., Ravi, C., Pathak, P., Angelahul, S. 2021. Museums and Heritage Sites: The Missing Link in Smart City Planning, a Case Study of Pune City, India. Space and Culture, India, 8, 4, 33-47. https://doi.org/https://doi.org/10.20896/sassy.v8i4.1072. Guerra, C. 2014. From Territory to Smartphone, Smart. Fruition of Cultural Heritage for Dynamic Tourism. Development. Planning Practice and Research, 29, 3. 238-255. https://doi.org/https://doi.org/10.1080/026974559.2014.9. 29837. Good, N., Ellis, K.A., and Mancarella, P. 2017. Review and Classification of Barriers and Enablers of Demand. Response in the Smart Grid. Renewable and Sustainable Energy Reviews, 72, 57-72. https://doi.org/https://doi.org/10.1016/j.arser.2017.01.043. Guo, M., Lu, Y, U, H, Hu, B, and Sang, Z. 2016. An Overview of Smart City in China. China Communications. 13, 5, 203-211. https://doi.org/10.1109/cc.2016.74899887. Harrison, C., Ekman, B., Hamilton, R., Hartswick, P. Kalagnanam, J., Parazazak, J., and Williams, P. 2010. Foundations for Smarter Cities. IBM Journal of Research and Development, 54, 4, 1-16. https://doi.org/https://10.1147/jrd.2010.20482557. Harvey, F. 1997. National Cultural Differences in Theory and Practice Evaluating Hofstede's National Cultural Framework. Information Technology and People, West Lynn. Or, 10, 2, 132-146. https://doi.org/https://doi.org/10.1108/09593849710174. 986. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 191. Hussain, F. Hussein, SM, Master, TA, Raysam, ARA. Samad, AM, Marof, I, and Hashim, KA. 2013. A. Review of Web-based GIs for visualization of George Town, Penang Sustainability as World Heritage Site 2013. IEEE International Conference on Control System Computing and Engineering. https://doi.org/10.1109/x.2013.67200004. Ken Durden, S. 2013. Pure Land, Inhabiting the Majao Caves at Dunhuang. Curator, The Museum Journal. 56, 2, 199-218. https://doi.org/https://doi.org/10.1111/kura.12020. Koshalham, K. 2018. Smart Heritage, Challenges in Digitization and Spatial Information Modeling of Historical Buildings. Second workshop on Computing Techniques for Spatio-Temporal Data in Archaeology and Cultural Heritage. https://doi.org/10.4230/lipics.coarch.2018. Kaukopoulos, Z, Kaukopoulos, D, and Jung, J.J. 2017. A. Trustworthy Multimedia Participatory Platform for Cultural Heritage Management in Smart City Environments. Multimedia Tools and Applications, 76, 24, 25943. 25981 https://doi.org/10.1007/S11042-017-4785-8. Larario, A., and Varaseno, A. 2020. An IoT Smart Infrastructure for Domenico Church in Mataras Sassi. A multi-scale perspective to build heritage conservation. Sustainability, 12, 16, 6553. https://doi.org/https://doi.org/10.3390/so12166553. Lee, J., Krishnamurti, S., Pereira Roders, A., and Van Wessemail, P. 2020. Community Participation in Cultural Heritage Management, a Systematic Literature Review comparing Chinese and international practices. Cities, 96, 102,476. https://doi.org/https://doi.org/10.1016/j.cities.2019.1024. 76. Lim, C., Cho, G.H., and Kim, J. 2021. Understanding the Linkages of Smart City Technologies and Applications, Key Lessons from a Text Mining Approach and a Call for Future Research. Technological Forecasting and Social Change. 120,893. https://doi.org/https:/doi.org/10.1016/j.tech4.2021.12 0893. Mar, A, Monteiro, F, Pereira, P, and Martins, J. 2018. An application to improve smart heritage city experience. Advances in Digital Cultural Heritage, CHAM. https://doi.org/10.1007/978-3-319-75789-6_7. Min, KD, Bui, NP, and Don, TM. 2021. Towards developing the smart cultural heritage management of the French colonial villas in Hanoi, Vietnam. International Journal of Sustainable Construction Engineering and Technology, 12, 1, 296-313. https://doi.org/https://doi.org/10.30880/ijsit.2021.12.01.028. Mitro, N, Kromida, M, and Amditis, A. 2022. Smart Tags, IoT sensors for monitoring the microclimate of cultural heritage monuments. Applied Sciences, 12, 5. 2315. https://doi.org/https://doi.org/10.3390/app12052315. Mouse Takas, K, and Soveres, D. 2010. Virtual simulation of cultural heritage works using haptic interaction. Berlin, Heidelberg. https://doi.org/10.1007/978-3-642. 12842-4_48. Nave, M. 2018. Would urban cultural heritage be smart? Culture as a land factor in Italian cities. Smartness. Revista de Comunicação e Linguagens, 48. Retrieved from https://rcl.fcsh.nl.pt/index.php/rcl/article/view/75. Picciali, F, and Chianesi, A. 2018. Editorial for FGCS. Special issue, The Internet of Cultural Things, Towards a Smart Cultural Heritage. Future Generation Computer Systems, 81, 514-515. https://doi.org/https://doi.org/10.1016/j.future.2017.12.0. 19. Pipatana Somporn, M, Feroz, H, and Raman, S. 2009. Multi-agent systems in a distributed smart grid, design and implementation 2009 IEEE/Peace Power Systems. Conference and Exposition. https://doi10.1109/PSCE.2009.48400087. Pocobelli, D.P., Boehm, J., Brian, P., Still, J., and Grau. Bov. J. 2018. BIM for Heritage Science, a review. Heritage Science, 6, 1, 30. https://doi.org/10.1186/S40494-018-0191-4. Chiu, J, Lee, J, and Sun, H. 2015. Innovative and Applied. Research on Big Data Platforms of Smart Heritage is sparse. Annals of Photogrammetry, Remote Sensing and Spatial Information Sciences, 25/W3, 257-261. https://doi.org/https/doi.org/10.5194/isparse annals 25. W3-257-2015. Riganti, P. 2017. Smart Cities and Heritage Conservation. Developing a Smart Heritage Agenda for Sustainable, Inclusive Communities. ArchNet IJAR, 11, 3, 16-27. https://doi.org/http/doi.org/10.26687/ArchNet. IJAR.v11 I3.1398. Rogers, P.P., Jalal, K.F., and Boyd, J.A. 2012. An Introduction to Sustainable Development, First ed. Routledge. https://doi.org/https/doi.org/10.4324/9781849770477. Sandford, R. 2019. Thinking with Heritage, Past and Present in Lived Futures. Futures, 111, 71-80. https://doi.org/https/doi.org/10.1016/j.futures.2019.06. 004. Journal of Contemporary Urban Affairs, 6, 2, 175-192/2022. PhD candidate Heng Song, Professor Dr. Gehan Selim 192. Selim, G, Jamhai, M, Abdelmanem, M.G., Mabday, S. and Holland, A. 2022. The Virtual Living Museum. Integrating the multi-layered histories and cultural practices of Gadara and Arsquo's archaeology in UMMKS. Jordan. Sustainability, 14, 11. https://doi.org/10.3390/SIR141167121. Selim, G, Jamhai, M, Holland, A, and Mabday, S. 2021. Digitizing Heritage as an Integrated Sustainable Tool for Informative Interpretation of the Past, the Case of UMM. KS, Jordan. Traditional Dwellings and Settlements. Review. Retrieved from https://eprints.whiterose.ac.uk/175344/. Sindhu, S., and Rishmai, M. 2020. Cultural Infrastructure and the Planning of Future Cities. E3s Web of Conferences. https://doi.org/10.1051/e3sconf/202017005001. Sneeze, UL, Olson, AK, and Bernhardt, I. 2021. Becoming a Smart Old Town: How to Manage Stakeholder Collaboration and Cultural Heritage. Journal of Cultural Heritage Management and Sustainable Development. 11, 4, 627-641. https://doi.org/https://doi.org/10.1108/jchmsd10-2020. 0148. Snyder, H. 2019. Literature Review as a Research Methodology, an Overview and Guidelines. Journal of Business Research, 104, 333-339. https://doi.org/https://doi.org/10.1016/j.jbusres.2019.07. 039. Stanojev, J., and Gustafsson, C. 2021. Smart Specialization. Strategies for Elevating Integration of Cultural Heritage into Circular Economy. Sustainability, 13, 7, 3685. https://doi.org/https://doi.org/10.3390/so13073685. Suwardi, D., Trizianti, S.W., Vertriana, R., Siamsu, A. Janati, S., and Halim, R.S. 2022. Heritage Smart. City Mapping, Planning and Land Administration. Hestia. Isperse International Journal of Geo. Information, 11, 2, 107. https://doi.org/https://doi.org/10.3390/ig11020107. 10, T. Mills, G., Paypadanakolaki, E., and Liu, Z. 2021. Combining Multi-Criteria Decision Making, MCDM. Methods with Building Information Modeling, BIM-A. Review. Automation in Construction, 121, 103451. https://doi.org/https://doi.org/10.1016/j.otkin.2020.103. 451. Tofek, M., and Mohammed, R. 2013. Smart Aspects 4. Safeguarding Heritage. Structural Studies, Repairs and Maintenance of Heritage Architecture 13, 131, 147. https://doi.org/https://doi.org/10.2495/str130131. Thwaites, H. 2013. Digital Heritage, What Happens When We Digitize Everything? In Visual Heritage in the Digital Age, pages 327-348. Springer. https://doi.org/https://10.1007/978-1-4471-5535. 5_17. Tranfield, D., Denier, D., and Smart, P. 2003. Towardsley. Methodology for Developing Evidence-Informed Management Knowledge by Means of Systematic Review. British Journal of Management, 14, 3, 207-222. https://doi.org/https://doi.org/10.1111/1467-8551.00375. Vasilakis, C., Poulopoulos, V. Antoniou, A. Wallace, M. Lepouras, G. and Noers, M. L. 2018, EXISTORY, Smart. Exhibits that tell their own stories. Future generation. Computer systems, 81, 542 to 556. https://doi.org/https://doi.org/10.1016/j.future.2017.10.0 38. M. 2010. A Definition of Cultural Heritage, From the Tangible to the Intangible. Journal of Cultural Heritage, 11, 321 to 324. https://doi.org/https://doi.org/10.1016/j.culher.2010.01.0 06. Vizen, M. and Syria, C. 2020. Smart City, Concepts and Two Relevant Components. International Journal of Computers, Communications and Control, 15, 2. https://doi.org/https://doi.org/10.158337/ijuk.2020.2.386. 7. Wang, Y, Dai, X, Jung, J. and Choi, C. 2018. Performance Analysis of Smart Cultural Heritage. Protection-Oriented Wireless Networks. Future Generation. Computer Systems, 81, 593 to 600. https://doi.org/https://doi.org/10.1016/j.future.2017.04.0 07. Wang, J.K., Li, H., and Wang, S. 2005. Intelligent Building. Research, a Review. Automation in Construction, 14, 1. 143 to 159. https://doi.org/https://doi.org/10.1016/j.otkin.2004.06 001. How to cite this article. Song, H. Selim, G. 2022. Smart Heritage for Urban Sustainability, a Review of Current Definitions and Future Developments. Journal of Contemporary Urban Affairs, 6, 2, 175 to 192. https://doi.org/10.25034/hqa.2022.v6n2-5